Although many people are fascinated by the idea of changing the past or seeing the future before it's due, no person has ever demonstrated the kind of back and forth time travels in science fiction, or proposed a method of sending a person through significant periods of time that wouldn't destroy them on the way. As physicist Stephen Hawking pointed out in his book Black Holes and Baby Universes, the best evidence we have that time travel is not possible and never will be is that we have not been invaded by hordes of tourists from the future. Science that supports some amount of time bending, though. For example, physicist Albert Einstein's theory of special relativity proposes that time is an illusion that moves relative to an observer. An observer traveling near the speed of light will experience time, with all its after effects, boredom, aging, etc., much more slowly than an observer at rest. That's why astronaut Scott Kelly aged ever so slightly less over the course of a year in orbit than his twin brother who stayed here on Earth. There are other scientific theories about time travel, including some weird physics that arise around wormholes, black holes, and string theory. For the most part, though, time travel remains the domain of an ever-growing array of science fiction, books, movies, television shows, comics, video games, and more. Einstein's theory of special relativity. Einstein developed his theory of special relativity in 1905. Along with his later expansion, the theory of general relativity, it has become one of the foundational tenets of modern physics. Special relativity describes the relationship between space and time for objects moving at constant speeds in a straight line. The short version of the theory is deceptively simple. First, all things are measured in relation to something else. That is to say, there is no absolute frame of reference. Second, the speed of light is constant. It stays the same no matter what, and no matter where it's measured from. And third, nothing can go faster than the speed of light. From those simple tenets unfold actual, real-life time travel. An observer traveling at high velocity will experience time at a slower rate than an observer who isn't speeding through space. While we don't accelerate humans to near light speed, we do send them swinging around the planet at 28,160 kilometers per hour aboard the International Space Station. Astronaut Scott Kelly was born after his twin brother and fellow astronaut Mark Kelly. Scott Kelly spent 520 days in orbit, while Mark logged 54 days in space. The difference in the speed at which they experienced time over the course of their lifetimes has actually extended the age gap between the two men. Can wormholes take us back in time? General relativity might also provide scenarios that could allow travelers to go back in time, according to NASA. But the physical reality of those time travel methods are no piece of cake. Wormholes are theoretical tunnels through the fabric of space-time that could connect different moments or locations in reality to others. Also known as Einstein-Rosen bridges or white holes as opposed to black holes, speculation about wormholes abounds. But despite taking up a lot of space or space-time in science fiction, no wormholes of any kind have been identified in real life. The whole thing is very hypothetical at this point. No one thinks we're going to find a wormhole anytime soon. Primordial wormholes are predicted to be just 10 to the minus 33 centimeters at the tunnel's mouth. Previously, they were expected to be too unstable for anything to be able to travel through them. However, a new study claims that this is not the case. The new theory, which suggests that wormholes could work as viable space-time shortcuts, was described by physicist Pascal Coiron. As part of the study, Coiron used the Eddington-Finkelstein metric as opposed to the Schwarzschild metric, which has been used in the majority of previous analyses. In the past, the path of a particle could not be traced through a hypothetical wormhole. However, using the Eddington-Finkelstein metric, the physicist was able to achieve just that. Coiron's paper was described in October 2021 in the preprint database arXiv before being published in the Journal of Modern Physics D. Alternate time travel theories. While Einstein's theories appear to make time travel difficult, some researchers have proposed other solutions that could allow jumps back and forth in time. These alternate theories share one major flaw. As far as scientists can tell, there's no way a person could survive the kind of gravitational pulling and pushing that each solution requires. Infinite cylinder theory. Astronomer Frank Tipler proposed a mechanism sometimes known as a Tipler cylinder, where one could take matter that is 10 times the sun's mass, then roll it into a very long but very dense cylinder. The Anderson Institute, a time travel research organization, described the cylinder as a black hole that has passed through a spaghetti factory. After spinning this black hole spaghetti a few billion revolutions per minute, a spaceship nearby, following a very precise spiral around the cylinder, could travel backwards in time on a closed time-like curve, according to the Anderson Institute. The major problem is that in order for the Tipler cylinder to become reality, the cylinder would need to be infinitely long or be made of some unknown kind of matter. At least for the foreseeable future, endless interstellar pasta is beyond our reach. Time donuts. Theoretical physicist Amos Ori at the Technion Israel Institute of Technology in Haifa, Israel, proposed a model for a time machine made out of curved space-time, a donut-shaped vacuum surrounded by a sphere of normal matter. The machine is space-time itself. If we were to create an area with a warp like this in space that would enable timelines to close on themselves, it might enable future generations to return to visit our time. There are a few caveats to Ori's time machine. First, visitors to the past wouldn't be able to travel times earlier than the invention and construction of the time donut. Second, and more importantly, the invention and construction of this machine would depend on our ability to manipulate gravitational fields at will, a feat that may be theoretically possible, but is certainly beyond our immediate reach. As you could see on this video, time traveling is for the moment just a matter of science fiction. There are books, movies, video games about it. It would be amazing, of course, but for the moment it's only science fiction because it's really difficult. There are, of course, some theories about it. In theory, you could do it, but practically it's impossible to do it. Who knows, in 100 years, maybe it's possible, maybe in 1,000 years, or maybe actually never is going to happen. We don't know. Let's see what happens. If you like the video, please give it a like, share, subscribe to the channel, and follow me also on Facebook and Instagram. This would help me a lot. Thank you very much and see you next time.